Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at Central Indian Institute of Technology and Management, Gurgaon. This college is affiliated to Meher Siddhanand University, Rohtak. Today I will discuss the topic residue. So, in previous lecture, I told you about Cauchy integral theorem, and so these things. But today I will discuss residue topic. So pole, I have already told pole singularity that if denominator is equal to 0, then you will get singular point, and at that singular point, if your function is analytic, that means that point is called a singular point, right? And for the pole, you need to put denominator is equal to 0, and you will get your pole. And I told you about simple pole and pole of order n, right? So these things I have already discussed. But now, what is residue? So first thing about residue is that we can find our residue only at pole singularity, not other singularities like essential singularity, removable singularity, and all these singularities. So we will find our residue only at pole singularity, right? So first, about the residue, we have our poles. If we have our poles, and we can have our pole simple poles and pole of order n. So both of the residue, means at simple poles how we will find our residue, and pole of order n, if we have our pole of order n, then how we will find our residue. So both topic I will discuss here. And there will be few examples also be here. So just look at the definition of residue. So let z is equal to a is a pole of pole of order m of a function fz. Means first we are taking pole of order m here, and C1 circle of radius r with center at z is equal to a, which does not contain any other singularities, right? It means no removable, no essential, no isolated, only pole singularity will be here. So just begin it again. Let z is equal to a is a pole of order m of a function f z, and C1 circle of radius r with center at z is equal to a, which does not contain any other singularity except z is equal to a. Then fz is analytic within this circle. R is less than z mod of z minus a less than r. That means z minus a means is a circle of radius r and at center a. This is the meaning of this line. R is less than mod z minus 1 a is less than r. That means this is a circle of radius r, and center at z is equal to a, right? So we have our Lorentz series here. So what is Lorentz series? Fz is equal to n is equal to 0 to infinity a n z minus a to the power n plus summation n is equal to 1 to infinity. You can take another constant bn here, or you can write here a minus 1, because this is a negative power term series, right? So n is equal to 1 to infinity b n z minus a to the power minus n. You can write a minus n here. So your series will be a minus 1, a minus 2, a minus 3, and so on, right? Now, where a n is equal to 1 upon 2 pi I integration c f z upon z minus a to the power n plus 1 dz. So this is your a n value, and this value is same as it is Cauchy integral theorem, right? And bn means coefficient of negative power terms. So coefficient of negative power terms, that means 1 upon 2 pi I, same as it is integration f z upon, and your power will be changed here, z minus a to the power minus n plus 1 into dz, right? And you can find your b1 here. So just put n is equal to 1 here, because n is equal to 1 means pole of order 1, या फिर pole of simple pole, we can say it simple pole. So b1 is equal to 1 upon 2 pi I, and this value will be fz dz is called a residue of fz at z is equal to a. and this is called simple pole residue. That means b1 can be your a minus 1 value. So because this negative power term coefficient a minus 1 here, so b1 and a minus 1 both are same. So just don't worry about it ki b1 kahan se aa gaya. Just these are notations. So b1 is equal to 1 upon 2 pi I r 2 pi I integration f z dz. This is the value of the residue at z is equal to a. So we can write it residue z is equal to a is equal to b1. Like if you have your series, if you have your function fz, suppose fz is given e to the power 1 by z, right? E to the power 1 by z. So for the pole singularity we need to find all we will just open our e to the power z expansion. So e to the power z expansion is 1 plus z square by 2 factorial plus z cube upon 3 factorial plus and so on, right? It means e to the power 1 by z expression will be 1 by z plus 1 upon 2 factorial into 1 upon z square plus 1 upon 3 factorial into z cube plus and so on. So that means that if you are getting b1 means a minus 1. So z 1 upon z means z to the power minus 1. So z to the power minus coefficient will be your a minus 1. And if you are getting only a minus 1 value या फिर b1 value, so that value, suppose 1 upon z is here. So z to the power minus 1 coefficient is 1, right? 1 into 1 upon z means a minus 1 is equal to 1. So that value a minus 1 will be your residue at z is equal to 0, because e to the power 1 by z, so 1 upon z. So if you will common 1 by z outside, so z is equal to 0 is your pole. So that means that value a minus 1 will be your residue. Right? Now there is another method, and this is very simple method to find residue of pole of order 1 या फिर simple pole के लिए. तो ये method हम हर बार apply करेंगे हर एक question के लिए, because by this method you can find your residue very easily. No, there will be no confusion here. So just look at here, method of finding residue. So first method is your residue at simple pole या फिर pole of order 1. Simple pole is called pole of order 1, right? So if fz has a simple pole at z is equal to a, so then residue of fa means if you will put z is equal to a, then your function will be changed into fa. That means you are finding a residue at of function fz at z is equal to a. So this will be your limit z tends to a, z minus a into fz. So fz is your given function, and you will calculate your a means singular point. So for the singular point you will need to put denominator is equal to 0. That means that singular point is your pole singularity, and you will find your residue at only pole. So z is equal to a is your pole singularity. So just taking limit z tends to a, z minus a into fz. There is a proof also here where it is coming from. This residue where is coming from. So proof is, so we have our Lorentz series. So same as it is, our Lorentz series is a naught plus a1 z minus a plus a2 z minus a whole square plus and so on. These are positive power terms, plus a minus 1 upon z minus a plus and so on, and on so on term will be 0, because we are finding our residue at simple pole या फिर pole of order 1. So for the pole of order 1, that means only one power negative power coefficient will be exist, and minus 2, minus 3, minus 4 and so on, all the coefficient will be 0. And what this is the definition of pole. If you have a function fz and you are just defining a pole of order 1, that means a minus m does not equal to 0, but a minus m minus 1, a minus m minus 2, all coefficient will be 0, right? Then you can say that there is a pole of order m. So pole of order m या फिर simple pole, so m will be your 1. So all other coefficient a minus 2, a minus 3, a minus 4, a minus 5 and so on till infinity must be 0. So just look at here. So just multiply on both side by z minus a here. So z minus a into fz is equal to this term. So we need to find the value of a minus 1. So a minus 1 is equal to the z minus a into f z minus these all terms will be go in the left hand side. So minus a naught z minus a plus a1 z minus a whole square plus and so on, right? Taking limit as z tends to a, because we are finding our residue at z is equal to a. So put z is equal to a, so a minus 1 is equal to limit z tends to a z minus a into fz. And if you will put z is equal to a here, that means all terms will be 0, because z is a minus a minus a whole square, so all will be 0, and you have left only a minus 1 is equal to limit z tends to a z minus a into fz. So this is your residue of pole of order 1. This is your residue of a simple pole. You can write it as residue of fa is equal to, that means you are finding a residue at z is equal to a minus 1 is equal to limit z tends to a z minus a into fz. Now you will better understand by this example. So determine the pole and residue at the pole of the function fz is equal to z upon z minus 1. So this is your given function. So we have fz is equal to z upon z minus 1. Now poles of fz are given by putting the denominator equal to 0, right? So just put denominator is equal to 0. So z is equal to 1 is a simple pole. We can see here there is only 1 here. No other one is here. So this is a simple pole, या फिर pole of order 1, right? So if z is equal to 1, that means you are getting your singular point a is equal to 1. Now we need to calculate residue at z is equal to 1. So for the simple pole, you have to learn your formula of residue. So residue is equal to limit z tends to a z minus a into fz. So we are putting z is equal to 1 here. So residue of fz at z is equal to 1 is equal to limit z tends to 1 z minus 1 into fz, right? And we have our fz, so just to put the value of fz here. So z minus 1 into z upon z minus 1, so both will be cancelled out, only z is here. And just to write the just put the value of limit here. So your residue of fz as z is equal to 1 is will be your 1. So hence fz has a simple pole at z is equal to 1, and residue at the pole is 1, right? There is another example, but we need to learn only one thing. If we have our simple pole, so always we will find our simple pole by use this method, right? Now there is another example here. Evaluate the residue of z square upon z minus 1 z minus 2 z minus 3 at z is equal to 1 2 3. One thing here, these are the 2 marks questions, 2.5 in BTech G scheme in MG Mahatma Gandhi University. These are the 2.5 marks questions, and these types of question always asked in your final semester exam. So just to try to understand difference between simple pole and pole of order M, right? Then after, if you got your definition clear about pole, then you can find your residue very easily. So just look at the example here. So the poles of fz are determined by putting the denominator equal to 0. So just put your denominator. So z is equal to 1, z is equal to 2, z is equal to 3. These are the simple poles, right? Because these are we are getting all these three at one time only. So these are the simple pole. Yeah, we can say that z is equal to 1 is a pole of order 1, z is equal to 2 is a pole of order 1, and z is equal to 3 is a pole of order 1. You can write all these three as. Now so we need to find our residue. So first pole is your z is equal to 1. So just find residue of fz at z is equal to 1. So we have to learn our formula. So formula is limit z tends to a z minus a into fz, and a is here 1. So limit z tends to 1, first line is your limit z tends to 1, a is replaced by 1, so z minus 1 into fz. So just write here fz, so z minus 1 cancelled out, so only remaining for function is here. Just put z is equal to 1, then you will get 1 by 2 at residue of fz at z is equal to 1. Now next simple pole is z is equal to 2, so just to find z is equal at z is equal to 2 residue. So limit z tends to 2, z minus 2 into fz. So limit z tends to 2, z minus 2 upon z minus 1, z minus 2, z minus 3. So this will value will be cancelled out. So we have our residue at z is equal to 2 is equal to minus 4, right? Same as it is residue of fz at z is equal to 3. So just limit z tends to 3, z minus 3 into fz. So just write the value and you have your residue is equal to 9 by 2. So these are 4 questions. This is your exercise. Just solve these 4 questions. And if you guys have any doubt, then I will provide you a solution of these 4 questions in our next video. So just try to solve this exercise. These are very simple questions. Just put denominator is equal to 0. So these are your simple pole for pole of order 1. So just find residue at these at your simple pole, right? At poles singularity. I will give you answer in our next video. All these 4 questions answer I will provide you. Now next is residue at a pole of order n. So we have discussed our simple pole residue. Now second point is residue at a pole of order n. So first we have to our pole of order n definition. So it means a minus m is equal to does not equal to 0 and other or 0 means you are getting your m is equal to 2, then we can say this is a pole of order m या फिर pole of order 2. That means more than one power होनी चाहिए हमारे पास में. So if fz has a pole of order n at z is equal to a, then residue at z is equal to a is equal to 1 upon n minus 1 factorial d to the power n minus 1 upon dz to the power n minus 1 z minus a to the power n into fz at z is equal to a. We are finding our residue at pole singularity z is equal to a. So what is here? What that means pole of order n. So there is a 1 upon n minus 1 factorial into d to the power n upon dz. D upon dz means differentiation with respect to z. So if you have pole of order 2 is here, so 2 minus 1 factorial 2 minus 1 upon dz to the power 2 minus 1, that means d upon dz. It means you have to differentiate one time with respect to z. जो भी आपका यहाँ पर फंक्शन आएगा उसका हम जितना भी n होगा उसके अकॉर्डिंग उसको डिफरेंशिएट करेंगे और लास्ट में just put z is equal to a at last, right? Now there is an example here, so you will understand pole of order n, how we will find our residue at pole of order n. So example is find the residue of a function fz is equal to at its double pole and also at simple pole, right? So just for the pole singularity we need to put denominator is equal to 0. So z plus 1 whole square into z minus 2 is equal to 0. So z is equal to minus 1, it means z plus 1 whole square means then you will get your minus 1 2 times and z is equal to 2 only one time. So z is equal to minus 1 is a pole of order 2 because we are getting z is equal to minus 1 2 times and z is equal to 2 we are getting only one time. So z is equal to 2 is a simple pole or pole of order 1 and z is equal to minus 1 is a pole of order 2. Now just first at find residue at simple pole. So residue at simple pole z is equal to 2 means limit z tends to 2 z minus 2 into fz. That means limit z tends to 2 z minus 2 fz value is your here, so just cancelled out and the value is 4 upon 9. That means one thing is clear that if simple pole, so we will apply our above method. Now for the pole of order 2, pole of order 2, that means pole of order n. So n is here 2, right? So put n is equal to 2 and residue at z is equal to -1 is equal to limit z tends to -1. A is your -1, 1 upon n minus 1 factorial d to the power n minus 1 upon dz to the power n minus 1 z minus a to the power n into fz. So limit z tends to -1 is we have, and put the value of n here. So 1 upon 2 minus 1 factorial d to the power 2 minus 1 upon dz to the power -1 z minus a is given -1, so z minus of -1 whole square into z square upon z plus 1 whole square into z minus 2, right? So z plus 1 z plus 1 whole square, these brackets will be cancelled out, and only z square upon z minus 2 will be here. And first just look at this point, d upon dz. That means you have to differentiate one time with respect to z. So you have your remaining function d upon dz is equal to, sorry, d upon dz z square upon z minus 2. So in numerator z function, denominator, so you will apply here u upon v, means fraction formula, and fraction formula is differentiation fraction formula v dot du. So v is your z minus 2 dot du means differentiation of u, so differentiation of z square will be your 2z minus u is z square, so u dot dv means z minus 2. Differentiation of z minus 2 will be z differentiation is 1 and minus 2 0, so 1 is here upon v square means z minus 2 whole square, right? Now you are getting z square minus 4z upon z minus 2 whole square, and this is this value at find z is equal to 1. So just write here z is equal to 1, then you will get 1 plus 4 upon 9 is equal to 5 upon 9. So you can calculate your total residue. To total residue, that means residue at simple pole, that means 4 upon 9, and residue of pole of order 2, that means 5 upon 9, and if you are adding both of them, then you are getting 1. So total residue value is 1 here, and the separate values are 4 by 9 and 5 upon 9. Students, I will share more examples and one or two exercise of residue, Cauchy-Integral theorem, and etc. So these will be these will topic these exercise I will provide you in your next video. Just today these are 4 question exercise, so just to solve these questions and try to understand the residue, and also try to understand difference between residue, a simple residue, and residue of order n, and learn both of the formula. So thank you.